Today we're going to go over the very basics of polar because I don't believe I've done so yet. Uh, Polar is a bit difficult to understand, although once you do grasp it, it is pretty intuitive. Let's go over the very basics before we jump into some of the equations. So polar is a field or a plane, much like xy, except this time it's represented by the distance from a center, which is going to be represented by r, and the angle at which that point is projected, which is going to be theta. Now, theta is the dependent variable, which is odd considering it goes second in the coordinate pair. But that's essentially what polar itself is. And in future videos, I'll make many more related polar videos. So these are the very few equations that we're going to go over today. The first one is tan theta equals y over x, because yes, polar can be translated to our typical rectangular plane. So tan theta equals y over x. You also have r squared equals x squared plus y squared. It may look familiar to you. The last is x equals r cosine theta and y equals r sine theta. So as you probably could have guessed, your typical polar equation is in terms of theta. So you end up with something theta. So that's just basic, very basic polar. Okay, so this is going to be our first equation. We're going to try to translate it into rectangular form. It's basically all we're doing today. So theta equals pi. As you know, tan theta, or if you'll recall, I should say, tan theta equals y over x, meaning that theta equals arctan y over x. If this is true, then arctan y over x equals pi, and therefore y over x equals tan pi. Tan pi is equal to, this is tan theta. Tan pi is equal to 0, and therefore our final equation is just y equals 0. Okay, so this equation that we have may look reminiscent to x equals r cosine theta. And in fact, it is, because we can just multiply this over here by r, or we can multiply, I should say, both sides of the equation by r. So we end up with r squared equals 3r cosine theta. Now here we can substitute x in for r cosine theta, so we end up with x squared. R squared equals 3x, and r squared is equal to x squared plus y squared. Therefore, our final equation, since I don't want to simplify, is equal to x squared plus y squared equals 3x. This equation looks a bit more difficult to translate into rectangular form, and that's because it is. So first, we're going to rewrite this. R is equal to 5 times 1 over sine theta, because that is what cosecant theta is equal to. So from here, we can multiply both sides by sine, and we end up with r sine theta equals 5. And so our final equation is y equals 5. Okay, this is our second to last equation. We have r equals 3 and r equals e, and we're going to try to translate into rectangular. So we could multiply both sides by r, and we'd end up with r squared equals er. That would be difficult to get rid of this r, even though we could substitute x squared plus y squared in for r squared. So rather than multiplying both sides by r, we're going to square both sides. So we end up with r squared equals e squared. Now r squared, as we've gone over a few times, is equal to x squared plus y squared. So x squared plus y squared equals e squared. And that is our final equation. This is our last question for today. We're told to find the slope of r equals 3 at theta equals pi over 3. And so, of course, you more likely than not don't know how to do this. So when asked to find the slope or tangent line, it's best to translate your polar equation into your rectangular equation. So x is equal to our cosine theta, y is equal to our sine theta, and our slope, which we'll call dy dx, is equal to dy d theta over dx d theta. And so these are the three things we have to find. Let's begin by finding the equation for x. So let's take r equals 3 and multiply both sides by cosine. So we end up with r cosine theta equals 3 cosine theta. And so our equation for x is 3 cosine theta. Same goes for y, except in place of r, we're going to have 3, or we're going to have, in place of sine, cosine, we'll have sine. So our equation for y is 3 sine theta, sorry. Okay, so we have our x and our y. Now let's find dy d theta, which is simply the derivative of 3 sine theta. And so we're going to end up with 3 cosine theta. And we can fill that in right now. From here, we just have to find dx d theta, which is the derivative of x, and therefore the derivative of 3 cosine theta. So we'll end up with negative 3 sine theta. And we can fill that in over here. And so from here, our dy dx is going to be equal to 3 cosine theta over a negative 3 sine theta, which is actually equal to negative cotangent theta at pi equals, when theta equals pi over 3. So our final answer for the slope of the line, or the slope of the curve r equals 3 at theta equals pi over 3 is equal to negative cotangent pi over 3. Now I don't have a calculator with me, so I can't figure out what that is, but I don't feel like simplifying anyway. So that's the final answer. If you have any suggestions for future videos, please put them in the comments. Thank you.